They are among the biggest explosions of radio energy in the entire universe.
This is one of the biggest beasts in the galaxy. It's a star also that is on the verge of death.
Betelgeuse is so big that if you were to place it in our own solar system, it would stretch to the orbit of Jupiter.
Despite costing billions and dragging for decades the most powerful telescope ever built by humans, the James Webb Space Telescope is paying huge dividends as it's giving us awesome insights into heavenly bodies that we wouldn't have had access to. One of its most recent discoveries is the disturbing truth about Betelgeuse. What is Betelgeuse and why are scientists so excited about what's about to happen to Betelgeuse? Stay tuned to find out. The James Webb Space Telescope is an incredible feat of engineering and science that has the ability to observe distant stars like never before. Orbiting the Sun about 1 million miles from Earth, this infrared observatory is designed to penetrate interstellar dust and make powerful observations of far-off celestial bodies. The telescope is able to find the first galaxies that formed in the early universe and to see stars forming planetary systems. This is an incredible achievement as it allows us to see the universe in greater detail than ever before. The telescope has already made many amazing discoveries, including finding dozens of galaxies that could be among the earliest known galaxies in the universe. One of the most exciting things about the JWST is its ability to observe star birth in stunning detail. To commemorate the first year of scientific operations by the James Webb Space Telescope, NASA released a stunning new image of a stellar nursery. The photo is gorgeous and showcases the process of stars being born a mere 390 light-years from Earth. This is the Rho-Ophiuchi cloud complex, the closest star-forming region to Earth. Given the nursery's proximity and JWST's unparalleled scientific instruments, we have never had this kind of crystal-clear view of these processes before. The detail revealed in this image of about 50 stars is truly remarkable, a distillation of all that Webb has delivered over the last 12 months and all that it promises to do over the next 10 or 20 years. This is a revelatory view of our own distant past. Our own star and solar system formed a little more than 4.5 billion years ago when a molecular cloud collapsed into what became our Sun. As the Sun formed, it did so with a large disk of leftover material surrounding it spinning. Over time, the material in this disk coalesced into the planets, large gas giants like Jupiter, and smaller rocky worlds like our own Earth. And now, billions of years on, humanity has developed civilization, science, and technology to finally look outward with enough precision to see this very process happening across the vast distances of the heavens. With the JWST, we are observing the very formation of brand new stars and protoplanetary disks all over again. And one of the stars the JWST is helping scientists to understand is Betelgeuse. Betelgeuse is a red supergiant star located in the constellation of Orion. It is usually the 10th brightest star in the night sky and after Rigel, the second brightest in the constellation of Orion. Its name is derived from the Arabic term Betelgeuse, which means the giant shoulder. John Herschel, an English astronomer, is considered a modern discoverer and the first researcher of Betelgeuse. In 1836, Herschel discovered that Betelgeuse was a variable star, meaning that its brightness changes as it expands and contracts. However, humans have noticed this bright star for a long time. For example, in the Almagest, a 2nd century astronomical treatise by Ptolemy, Betelgeuse is listed as one of the 48 stars in the constellation of Orion. Ptolemy also gives its coordinates and magnitude and describes it as having a reddish hue. Similarly, in the Alfonsini tables, a set of astronomical tables compiled in the 13th century by order of King Alfonso X of Castile, Betelgeuse is named El Dira, meaning the arm or the hand. The tables provide its position, motion, and brightness for various dates. In the Book of Fixed Stars, a 10th century catalogue by the Persian astronomer Abd al-Rahman al-Sufi, Betelgeuse is called Yad al-Jawza, meaning the hand of Orion. Al-Sufi also gives its color, magnitude, and position relative to other stars in Orion. Betelgeuse is a red supergiant star of spectral type M12 and one of the largest visible to the naked eye. Its apparent magnitude varies between 0 and positive 1.6, making it the first magnitude star with the widest range of variation. And at near-infrared wavelengths, Betelgeuse is the brightest star in the night sky. And if it were placed at the center of our solar system, its surface would lie beyond the asteroid belt and would engulf the orbits of Mercury, Venus, Earth, and Mars. For various reasons, its distance has been quite difficult to measure. Current best estimates are on the order of 500 to 600 light-years from the Sun, a comparatively wide uncertainty for a relatively nearby star. Its absolute magnitude is about -6. Less than 10 million years old, Betelgeuse has evolved rapidly because of its large mass and is expected to end its evolution with a supernova explosion, most likely within 100,000 years. Betelgeuse is a red giant star that's about 7,500 to 14,000 times brighter than the Sun. It is also about 700 times bigger than the Sun and 126,000 times more luminous. The prominent bright hot spot on Betelgeuse alone is about 400 times larger than the Sun. Betelgeuse is much more luminous than the Sun. Its luminosity is about 10,000 times that of the Sun. This means that Betelgeuse emits an enormous amount of light and energy, making it one of the brightest stars in the night sky. The brightness of Betelgeuse is due to its large size and high temperature. As a red giant star, Betelgeuse has expanded to an enormous size and its outer layers have cooled, giving it its characteristic red color. However, its core remains extremely hot, fueling the nuclear reactions that power the star. In comparison to the Sun, Betelgeuse is much larger and more luminous. The Sun is a main sequence star, meaning that it's in the prime of its life and is steadily burning through its supply of hydrogen fuel. Betelgeuse, on the other hand, has already exhausted its supply of hydrogen fuel and has expanded to become a red giant star. But Betelgeuse is not only a bright and large star, but also a variable and unstable one. It undergoes changes in brightness and size due to its complex internal dynamics and interactions with its surroundings. Betelgeuse is a semi-regular variable star, meaning that it has periodic cycles of pulsation, but also irregular fluctuations that aren't well understood. These pulsations cause the star to expand and contract by tens of % over periods of months or years. The pulsations also eject gas and dust from the star's surface into space, forming a thick envelope around it. This envelope can obscure the star's light and make it appear dimmer or redder at certain times. Moreover, Betelgeuse has huge cool spots on its surface, similar to the sunspots on our Sun, but much larger and darker. These spots can cover up to half of the star's visible disk and affect its brightness and color as well. Now, Betelgeuse is one of the easiest stars to see with the naked eye from Earth. It can be seen throughout most of the year in both hemispheres, except for late spring and early summer when it's too close to the Sun. The best time to see it is in winter when Orion is high in the sky at night. To find Betelgeuse, first locate Orion's belt, which consists of 3 bright stars in a row. Then look above and to the left of the belt for a bright reddish star. That is Betelgeuse. You can also use apps or websites that show you the position of stars and constellations in real time based on your location. Seeing Betelgeuse with the naked eyes is an amazing experience that connects us with the wonders of the universe. Betelgeuse is a star that has a lot to teach us about stellar evolution, variability, and supernovae. In late 2019 and early 2020, Betelgeuse underwent an unprecedented and unexpected dimming that puzzled astronomers and sparked speculations about its fate. Betelgeuse has been observed for centuries by astronomers and stargazers who have noticed that it has a regular cycle of brightness variation of about 400 days. This cycle is caused by the pulsation of the star, which expands and contracts its surface layers periodically. But Betelgeuse also has irregular fluctuations in brightness that are not well understood, but are thought to be related to its complex internal dynamics and surface features. In October 2019, astronomers noticed that Betelgeuse started to dim more than usual, reaching its lowest brightness in February 2020. The star lost more than 2/3 of its normal brightness, dropping from an apparent magnitude of 0.5 to 1.6. This was the lowest brightness ever recorded for Betelgeuse, and it made the star visibly fainter in the night sky. The dimming of Betelgeuse attracted the attention of many professional and amateur astronomers who used various instruments and methods to monitor the star's behavior. Some of the instruments and methods used were the Very Large Telescope at VLT in Chile, which is one of the most powerful optical telescopes in the world. It was used to take images of Betelgeuse's surface before, during, and after the dimming, showing how its shape and brightness changed over time. The Hubble Space Telescope, which is a space-based telescope that observes in ultraviolet, visible, and near-infrared wavelengths, was used to take spectra of Betelgeuse's atmosphere before and during the dimming, showing how its temperature, density, and velocity changed over time. The Atacama Pathfinder Experiment Apex in Chile and the James Clerk Maxwell Telescope at JCMT in Mauna Kea in Hawaii, which are radio telescopes that observe in sub-millimeter wavelengths. They were used to measure the amount of dust around Betelgeuse before and during the dimming, showing how it affected its brightness. And finally, the American Association of Variable Star Observers, which is an organization of amateur astronomers who observe and report on variable stars. They were used to collect photometric data on Betelgeuse's brightness from different locations and times, showing how it varied over time. By combining these observations and data, astronomers were able to study Betelgeuse's dimming in detail and try to find out what caused it. So what exactly was the reason for Betelgeuse's dimming? Several hypotheses were proposed to explain Betelgeuse's dimming, such as 1. A large cool spot on the star's surface caused by convection or magnetic activity. 2. A cloud of dust forming in front of the star caused by mass ejection or stellar wind. 3. A combination of both a cool spot and a dust cloud. And 4. A sign of an imminent supernova explosion. Supporting the third theory are the observations and data from different instruments and methods, which led some astronomers to conclude that the most likely cause of Betelgeuse's dimming was a combination of a cool spot and a dust cloud. According to this scenario, Betelgeuse had a large cool spot on its surface that covered about a quarter of its visible disk. This spot reduced the star's temperature and luminosity locally. The cool spot also triggered a mass ejection from the star's surface into space. The ejected material then cooled down as it moved away from the star and formed dust grains. The dust cloud blocked some of the light coming from Betelgeuse's surface, making it appear dimmer from Earth. Now, this scenario is supported by several pieces of evidence, such as the images from the VLT showed that Betelgeuse had an asymmetric shape and brightness during the dimming, indicating that there was a cool spot on its surface. The spectra from Hubble showed that Betelgeuse had a high velocity outflow during the dimming, indicating that there was a mass ejection from its surface. The sub-millimeter observations from Apex and JCMT showed that Betelgeuse had a higher amount of dust around it during the dimming, indicating that there was a dust cloud in front of it. And the photometric data from the American Association of Variable Star Observers showed that Betelgeuse's brightness varied in different wavelengths during the dimming, indicating that there was a dust cloud with different optical properties. The scenario of a cool spot and a dust cloud also explains why Betelgeuse recovered its normal brightness in May 2020. As the star continued to pulsate, the cool spot faded away and the dust cloud dispersed, allowing more light to reach Earth. And the scenario of a cool spot and a dust cloud also rules out the possibility of an imminent supernova explosion. Betelgeuse is expected to explode as a supernova at some point in the future, but there is no evidence that it's close to doing so. The dimming of Betelgeuse was not caused by any change in its core or internal structure, but by a surface phenomenon that is common for red supergiant stars. Betelgeuse is likely to continue to vary in brightness and size for thousands or millions of years before it finally explodes. However, what if Betelgeuse does become a supernova? That right there is a celestial spectacle right on our doorstep. Betelgeuse, one of the brightest and most recognizable stars in our night sky, might just be ready to put on the show of a lifetime, transforming into a supernova. Now, what will such a supernova look like? Well, imagine walking outside on a clear night and finding the familiar constellation of Orion Now picture his left shoulder, the distinctive red supergiant Betelgeuse, suddenly blazing brighter than the full moon. The sky would become a celestial theater, and we would all have front row seats to an astronomical extravaganza that hasn't been seen from Earth in centuries. And a supernova from Betelgeuse would be a cosmic light show the likes of which modern humanity has never witnessed. It would be a celestial spectacle of grand proportions, a testament to the universe's beauty and power. During the daytime, Betelgeuse's brilliance would outshine every other celestial body in the sky barring the sun, casting faint, ghostly shadows even in the bright light of day. Imagine an additional source of light like a second, smaller sun glowing in our daytime sky for weeks or even months. Isn't that an exciting prospect? This fantastic occurrence would transform our perception of the day-night cycle and make astronomy a part of everyone's daily life. As the supernova evolves, professional and amateur astronomers alike would be treated to an astronomical feast. The luminous event would provide an unprecedented chance to study a supernova's life cycle in real time, from its initial brilliant outburst to its slow dimming. It would enable scientists to witness firsthand the violent death of a massive star and the subsequent distribution of elements necessary for the creation of new stars, planets, and even life. The explosion would send a rush of neutrinos ahead of the light, which would be detected on Earth within minutes of the event by neutrino observatories worldwide. The neutrino burst would be our first sign that Betelgeuse has exploded, a clear herald of the spectacle to follow. And these tiny elusive particles would offer additional insights into the inner workings of supernovae, enriching our understanding of the universe. Isn't that absolutely thrilling? Yet, despite the brilliant, day-bright spectacle that a supernova would create, it's essential to reassure everyone there's no danger to Earth. Supernovae are undoubtedly powerful, but Betelgeuse is far enough away, over 600 light-years distance, that its death throes pose no risk to our planet. This means that we can appreciate the show without any fear, merely enjoying the cosmic marvel from the comfort of our home planet. Over time, the supernova's light would fade, and eventually Betelgeuse would disappear from our view entirely. But it won't be the end. The supernova's remnant would continue to radiate across the electromagnetic spectrum for years, offering scientists an abundance of data to help further unravel the mysteries of supernova explosions and the universe at large. Telescopes tuned to different wavelengths from radio to X-ray would track the evolution of the supernova's aftermath. Astronomers and astrophysicists would have a wealth of information to keep them busy for decades. So just think about it. If Betelgeuse does go supernova in our lifetimes, it would be nothing short of extraordinary. A once-in-a-lifetime, if not millennia spectacle that would illuminate our skies and our minds, filling us with a sense of wonder and awe. We'd be able to witness one of the most spectacular events in the cosmos firsthand, an opportunity that countless generations before us have only dreamed about. So when will this supernova occur? The exact timing of Betelgeuse's supernova is uncertain and hard to predict. Astronomers don't know precisely how much fuel is left in the star's core or how fast it's burning it. They also do not know how long it will take for the iron core to reach the critical mass, or how long it will take for the shock wave to reach the surface of the star. Some estimates suggest that Betelgeuse could explode within 100,000 years or even sooner. However, other estimates suggest that Betelgeuse could last for another 1,000,000 years or longer. Therefore, it's possible that Betelgeuse could go supernova within our lifetime, but it's also possible that it could go supernova long after we're gone.